So we move into step number 3. We move into step number 3 down here. Step number 3, where we are going to now plot. We shall sketch the above constraints on a graph. We shall have a sketch. Okay, we are going to sketch, or I can simply say plot the above constraints on the graph. So the constraints in step number 3 are plotted on the graph, but before you do that, you need to have a sketch. You need to have a sketch. So I'm going to share the graph for this particular question from one of my students, so that bigger than now. Now, number 1, when you are doing the graph, the graph must cover 3/4 of the graph paper. Okay, the graph must cover 3/4 of the graph paper. Now, what do I mean by that? The way you have seen what my very brilliant student here did, had to measure 1 centimeter. I think this is a 1 centimeter or 2 centimeters, even if they are 2 centimeters, and they drew the y-axis. Then they had to, this is exactly 1 centimeter from the boundary. Okay, 1 centimeter from the boundary, and they drew the x-axis. So this graph, yes, it is close to being 3/4, but as you can see, it is still a bit small. It is still a bit small. If this student had made the x-axis bigger, it would have been good enough to cover 3/4. So the y-axis is okay. The scale used on the y-axis is okay. The scale used on the x-axis is not okay. Now, this student is not limited to using this graph paper in portrait. You're not limited to using the graph paper in portrait. You can also use it in what? In landscape. You can turn it. If you see that the scales are not giving you 3/4, you can turn the graph. So, our rule number 1 in the exam, ensure that the graph covers 3/4. Okay, that is rule number 1. Let me even type it here in the Word document. Rule number 1, graph must cover 3/4. What is going to help you to get the 3/4 is the scale. You must get an appropriate scale which can give you 3/4. Now, the next rule is that the graph must have well labeled axes. The axes must be well labeled. For example, the student used y-axis. This I think was our activity B, which we have called activity B, and then here we have x-axis, which is activity A. So the axes must be well labeled. You must tell us what you have on your y-axis and what you have on your x-axis. So I'm going to include that, well labeled axes. Number 3 is that you must, before you begin with a graph, you must have a sketch. Yes, the sketch is given here, but this sketch should not be done on the graph paper. Members, the sketch should not be done it should be done in the answer booklet. You must sketch and determine where your lines are going to pass. Where is resource 1 line going to pass? Where is resource 2 going to pass? Where is resource 3 going to pass? So you must have a sketch. That is our rule number 3 before working with the graph, make a sketch. Make a sketch. Next, the graph must have a scale like this one here. This scale should be in the right hand corner. Make sure your scale is around here, below the title, in this free space. Here is where you put your scale. That's where you're going to put your scale, right here. So this student should have shifted the scale up. Now, how is the scale stated? Now, making use of the graph that we have here, we would come here and say this is our scale. Come and say this is our scale. Oh, I don't know that my things are going to be visible. So you come and put your scale right here, and then you say 1 centimeter. Now, for the vertical scale, as you can see, the vertical is the y-axis. These are 2 centimeters. So the student would have said 2 centimeters represent 1 unit. Okay, so you would come here and say, I hope you will be able to see. Let me just make it bigger. You come here and say the scale, then you would say vertical scale, then you say 1 centimeter represents 1. Actually, those are 2 centimeters. When I look at the size used, what the student used, those are 2 centimeters. 2 centimeters represent 1 unit. 1 unit in the sense that this is only 1. This is a 1. If I just take it back, this is a 1. This one here. This is the one I'm talking about, because the student is using 1, 2, 3, 4, 5. So it means that the gap between is a 1, 1, 1, 1. So 2 centimeters are representing 1, 1, 1, 1, 1. Now, for the case of the horizontal scale, the x-axis, as you can see, this is a 1 centimeter. I'm very sure 1 centimeter represents 1 unit, because the student kept on skipping 1, 1, 1, 1, 1. So you come and say here in the scale, I hope you'll be able to see my scale. You come and say the horizontal, horizontal. You'll say 1 centimeter represents 1 unit. So that will be enough. Vertical scale, 2 centimeters represent 1 unit. Horizontal scale, we put the word scale, 1 centimeter represents 1 unit, and put it in that corner. Okay, so don't wisecrack the way this student is wisecracking. He's playing around with the graph. He's putting the scale here, then he's putting the sketch here. No, don't play around with the graph. This is clean work. Don't put this one here. Okay, put it in the answer booklet. Then also the scale, don't put it here. Put it in the put it in the corner. Now, as our rule number 4, state the scale. State the scale used in the right format. I've given you the format, in the right format. Assuming I use my own, like the way the student did here. See the student, let us learn from the student. What the student did is saying in the scale, x-axis 1 to 1 unit, y-axis 2 centimeter to 1 unit. Okay, this one can also work, but please, that's the format we have agreed. When we are marking, we have agreed on that format. So be as responsible as possible. Then don't put these things that June 2012 question 6 don't put them here. Here what I expect is the title. Okay, I expect the title. So your graph should have a title, and the title should not be written in ink. Ink should not touch the graph paper. The way the student did it, he's not complying. Ink, whatever you do on the graph must be in pencil. Whatever you do on the graph must be. Okay, if you want to experiment, say, but this lecturer here, me, I'll use a pen. You experiment by using a pen. You see how the results will come out. You say, but I did everything. I did the graph very well. What happened? You used a pen. You used a pen. Pen ink does not touch the graph paper. We use pencil. Even when you're labeling, this labeling, you don't use ink. Don't use ink when you're labeling the axes. The examiner, the person marking, you will see. They will see everything. So ensure that the title is there, and any title can do. For example, let us read through. He's saying a graph showing resource usage and amount available for each activity 1 and 2. Perfect. Very nice title. This title, pick all the marks allocated for the title. Very nice title. Of course, I'm saying any title can work. Don't put a funny title that activity 1 and 2 available resources and whatever. If it is a funny title, we are not going to mark it. We are not going to mark that title. So our next rule is an appropriate title. The graph should have an appropriate title. The next rule is the beginning of your graph. Under linear programming, not for all other graph work, only linear programming. Your linear programming, your graph should begin from 0, from the origin, as you can see what the student did. So the student is showing a general O. You should show the 0 for X, show the 0 for Y. The graph must begin from the origin. The graph must begin from the origin. Let me type that rule. The graph must start or begin from the origin. Origin is O 0 0 0 0, coordinate 0 0, coordinate. Now, because the graph begins from the origin, it means that all lines are going to cut the graph, the axis at, okay, they are going to cut the axis. This is what I'm saying. One of the coordinates is going to be a 0. For example, our student here was very, very accurate. He did the 2. I think this is the 2x plus 4y is equal to 20. That is resource number 3. This is correct. What the student did was correct. As you can see, the line is cutting at 5 and at 10. So the coordinate here is 0, 5 and 10, 0. So it means that each of these lines, one of the coordinates is going to be a 0, because the graph cuts, the lines cut the 2 axes. Okay, they will go through the axes. Then again, we have this other one here. 2x plus y is equal to 10. This is resource number 1. This is resource number 1. Again, resource number 1 is cutting the axes at 2 points at 10. So that is 0, 10, and also at 5. That is 5, 0. So those are the 2 coordinates making up the line 2x plus y. Okay, those are the coordinates. Then finally, resource number 2, this one here, 3x plus 3y is equal to 18. That is the line. I think this is the one. 0, 6 and 0, 6 and 6, 0. 0, 6 and 6, 0. So that is how we end up with our 3 lines describing the constraints all the inequalities. So let me just pick up that rule. All the inequalities must cut through the x and y axis. Now, because these are inequalities, we must shade the required region. We must shade the required region. Now, the required region, as he indicates here, is what we call the feasible region. That's what we call the feasible region. Okay, we call that one the feasible region. Feasible region. Now, in its definition, the feasible region is the region that contains the points that will maximize the what? That will maximize the objective function. Now, the shading, how is the shading done? As you can see, he did the shading nicely. Okay, you see that shading? I hope you're able to see the shading. He's shading off the unwanted region. He's shading off the unwanted region. And also what he forgot was to shade off this negative side. The negative side. The negative side. The negative side. You are supposed to shade off. But of course, you don't shade and cover the labels. You shade nicely. You shade nicely. You shade off the unwanted region. So at the end of the day, you're going to remain with this region here. And that's what we call the feasible what? That's what we call the feasible region. So these are our rules. Let's pick up these. We can practice them again. Rule number 1, graph must cover 3/4 of the graph paper. Rule number 2, well labeled axes. Rule number 3, before working with the graph, make a sketch. Rule number 4, state the scale used in the right format. Rule number 5, the graph should have an appropriate title. Rule number 6, the graph must begin from the origin. Rule number 7, all the inequalities linear lines must cut the graph through the x and y axis. Rule number 8, the shading must be done to indicate the feasible region. So marks are going to be allocated like that. Marks are going to be allocated like that. Now, after plotting those inequalities on the graph, we now go to step number 4. We read off the vertex points of the feasible region. The first feasible region is this one here, 0, 5. I'm going to call that one A. No. I'm going to call it, how can I label my vertex points on the graph or not allowed? Yeah, you can label. You can call this one P. Let's call this one P. This is going to be our P. P is 0, 5. Region, we have point P, which I'm calling point P. Point P. Point P. Point P is 0, 5. 0, 5. Then we can get the next one. Next one is, I'm going to call this one Q. Q, I can see is 2, 4. This one, I'm going to call it point R. Point R. R is about roughly 4, 4, 2. The last one, which I can call S. S is 5, 0. 5, 0. That is point S, which is 5, 0. Which is 5, 0. So those are the vertex points of the feasible region. Now, after getting the vertex points of the feasible region, we now substitute these vertex points in the objective function. Substitute these in the objective function. Our objective function is basically this one here. That is the objective function. So meaning that at point P, we are going to have something like this. We shall substitute. So where we have A, we shall put a 0. Where we have B, we shall put a 5. So there we shall get the contribution at that point. Then next we go to point Q. Where we have this 0, it's a 2. Where we have the 5, it is a 4. So we look for that figure. Yeah, 4 and 2. Then at point S, we have 5 and 0. 5 and 0. So let us solve. At point P, this is how much? 15,000. At point Q, 16,000. Okay, 16,000. At point R, how much is that? Then this one is 10,000. So we see profit being maximized at point Q. Okay, point Q is the point at which we maximize our profit. This is the optimum point. So as the examiner required us to do, in Roman 1, we were required to formulate the linear programming model of the problem. The linear programming model is step number 1 and 2 is the linear programming model, the objective function and the equations of the constraints. So we have answered that. Roman 2 of the question, they want us to use the graphical method to solve the model. That is what we have done. We have plotted the graph, looked for the vertex points, substituted in the objective function, and we have got the point of maximization. Then Roman 3, to find the resources of each activity that maximize the objective. Fine. 2, type 1, activity 1, okay, and then 4 of activity 2. Those are the ones that are going to maximize. If we are talking about products, then we can say we can produce 2 units of product A and 4 units of product B to maximize profit.